Hello everyone. In this topic, we will start introducing the basic syntax in Kotlin. So, first we will talk about the data types and variables. Then we will learn what's the control structures, what's the if, and okay, a similar one. And actually, it's an improved one called when. Then the loops. Afterwards, we will introduce the functions, how to define a function, and for a lambda function. Okay, lambda is kind of function, but it's a little bit different. We will also introduce how to use lambda. Then conclusion. So the first one, the data types in Kotlin. Kotlin has a concise way for uh, using the data types similar to Java. So basically, we have some data types. For example, int, uppercase I. So int, it corresponds to integer, integer, wrapper class, double, float, boolean, and string. So it's easy to understand the data type, the corresponding data type in Java. And in Kotlin, everything is an object. So it allows us to call the member functions and properties on any variable. And that implies in Kotlin, when we use an int, even it's a literal int value, we can consider the literal as an object, int object. Okay, so there are associated methods for the int object. Okay, then declaring the variables. For declaring variables is straightforward. We may use the VAL, means value, for immutable variables. So immutable is similar to the final keyword in Java. Okay? That means we can assign the value once. Okay? For a true variable, uh, we use VAR for mutable ones. Then the beauty of Kotlin is its type inference. For many cases, we don't need to explicitly specify the type. For this example, we say VAL name. Right? Uh, if if we insist specifying its type, we need to specify that it's a string. Right? Name is a string. However, for this statement, it's pretty clear because it is assigned. Right? The variable is assigned with a value, a string value. So name, its data type can be derived from the initialization value, and it's a string. Okay? So this is called the type inference. Okay? You don't always need to specify the type explicitly. And uh, however, you can declare it explicitly. By explicitly declaration, you just use a column, a name column string, the data type string. For Java, we use the form that uh, data type and then uh, identifier. In Kotlin, we use the keyword VAL or VAR, followed by the identifier and optionally the data type. For specifying the data type, we use column data type. Okay. Okay, so Kotlin's type inference eliminates the need to explicitly specify the type in some cases. Then, uh, the VAL, as we mentioned, is like final keyword in Java. Once assigned, its value cannot be changed. With VAR, with var, we can reassign the value. So Kotlin encourages using VAL over VAR for immutability, resulting in a safer and more predictable code. Some people may concern that by creating immutable objects, uh, it may have a great impact to the runtime because we may um, recreate this objects for the same value again and again. Uh, However, this is not true. Okay, according to some research, by using the immutable objects or immutable values, we can use some optimization mechanism to reduce the impact. And after the incorporation of the underlying mechanism, uh, it's better. Okay? It shows better result for using immutable variables, okay, in many cases, especially for multi-threading environment or multi-process environments. Okay, then let's talk about the control structure. Uh, for control structure, it's quite similar to Java, but with some uh, enhancements. Okay. The if statement in Kotlin works like Java, but it can also be used as an expression. So it's quite convenient. The if statement is also an if expression. So we can, okay, for example, like this, a variable called result, and then given if condition, right? If the condition is true, result is the string yes. Otherwise, it's the string no. So it's similar to the ternary operator in Java, right? However, we use a more expressive syntax, right, to replace, right, the ternary operator. Okay, so Kotlin's control structure include if, right, including if, when, and loops offer enhancements compared to Java. Right, this is one of the examples. Okay, for the next one about the when statement, uh, Kotlin, right, replaces the switch statement with when. Right? Remember, we have the switch statement, switch case, and usually we will use the break statement along with the switch. So it's a more powerful and flexible version. You can use when as an expression or a statement. Okay? For example, this one is an example when, okay, x equals 1. Okay? It the return value, or you may consider when, right, returns the string 1, otherwise string 2, otherwise others. So, although it's not exactly the same as does not covers all the usage scenario of the switch. However, it can be used for replacing the switch, especially for the frequently or the common usage of the switch. Just some matching cases. Okay? Just match one case and uh, do something, or in this example, we just return something. Okay, so this is the when statement. When statement can be used in some there is an alternative form, but now let's keep learning just one. Right? We will just learn one of the form of when, okay, so that you will not get confused. Okay, then the loops. Loops. Loops in Kotlin are similar to Java. Okay? We have for loop, while loop, and do while loop. However, especially however, the for loop is actually the iterative for or the for each loop. We don't have the conventional for loop support in Kotlin. So if you need something like a conventional for loop, you need to fall back to use the while syntax. So the for loop is just used for iteration, right, through a list of items. So it's actually the iterative for in Java. The for loop is powerful when combined with Kotlin's range expression. For example, 1.5 means 1 to 5, and 1 to 5. Okay, then Kotlin also has a function called for each, for iterating through over collections, which is covered in some later topics. Okay? It's more general, more general than the iterative for. Okay, and let's talk about the functions. Functions are the building blocks of Kotlin programs. We define a function in this way using the keyword fun, F-U-N, and followed by the name, and the list of parameters and the return type. So I think the lower part of this point shows a regular function, the keyword fun, and the function name aid, the list of parameters. So identifier, colon, data type, identifier, colon, data type. For the function return type, colon, return type. Okay, so we specify that aid. This function aids two integers and returns an integer. So we return a plus b. In Kotlin, we can choose the form like this. This is called the single expression function body. So for example, we just return a plus b. So we can simply define that the function body equals a plus b. Okay? So it becomes more clean, clean in terms of the code. So the concise syntax for single expression functions allow the return type to be inferred. Actually, we can omit this part because A is int, B is int, and A plus B should be int. So the return type can be inferred using the infer mechanism. Right? Okay, then function, right, can the function parameter can be associated with a default value. So Kotlin also supports default and named arguments, making function calls more readable and versatile. For example, we can specify or we can define function greet with a name and message. The default message is hello. So when we call greet John, the result would be hello John. Hello John. And here is a syntax. You will see that it's double quoted, and then we directly specify $MSG $name. So this you may consider this is a string interpolation. So this is a string template, and then we can just use the value inside the variable to replace this part, this part. Okay, then this is about the default values. For named arguments, right, named arguments allow you to specify the values of specific parameter when calling a function regardless of their order. So sometimes, suppose we would like to provide the message first and then the name second as the second argument. We can just specify MSG equals something, okay, when calling for example, greet MSG equal hi, comma, name equal John, okay, like this. Okay, so now let's talk about the lambda. Okay, uh, lambda calculus is interesting. So lambdas are anonymous functions that can be passed around as values in Kotlin, which has a strong focus on functional programming. Actually, lambda calculus comes from the field of functional programming. Lambdas are often used with collection operations in Kotlin. You may consider lambdas as an in-place definition of a callback function. Okay, something like that. Okay, uh, that means we pass the function in C. If we would like to pass a function as an argument to the function call, we need to define the function and pass the function pointer. With the help of lambda, we can just directly define the function at the location of the argument. Right? When calling the function, we just define the lambda in the at the location of the argument, and then that means the function body is directly defined. So the function does not require a name. Okay? We just need to define the body of the function. So this is a so if we would like to define the lambda as a variable, okay, this is an example. We call it sum. Okay, equal lambda is enclosed by curly brackets. So we use curly bracket to include that for the right arrow, okay, right arrow, the left part of the right arrow is the list of parameters. So A and B, they are integers. The right part, or the right hand side of the right arrow specifies the calculation. So A plus B. Okay. So again, let's say lambda is an anonymous function that you can pass around as values, and uh, the lambda can be considered as an in-place definition of a callback function. So this is a quick conclusion of the Kotlin syntax basics. How to declare a variable. We have two ways, VAL and VAR, or immutable and mutable. How to specify the variable identifier and how to specify the type of a variable, and how to define a function using the fun keyword and function name, parameter list, and return type, and then function body. If the function body is a single line expression, we can directly use an equal sign to specify the expression. The special kind of function is called lambda. It can be used as a data object for passing the calculation algorithm as a kind of value, as a parameter, as an argument. So you may consider it is an in-place definition of a function body. Okay, so this is a quick introduction of the fundamental part, and we didn't introduce the array concept in uh, Kotlin because it's pretty straightforward. Uh, because we once we know how to declare a variable, actually we can have an array. But later we will have I will give you some examples about the arrays.